Students, let's continue with acceleration due to gravity. Now in this next module, we'll understand an expression for acceleration due to gravity at a height in terms of acceleration due to gravity on the surface. Okay, let's start. Let's first start with acceleration due to gravity at a height formula. You remember in the previous module we understood the acceleration due to gravity at a height is represented as gh. And the formula for gh is given as gm upon r plus h the whole square, where r is the radius of earth and h is the height from the surface of the earth where you are going to measure this acceleration due to gravity. Now we want the formula for gh in terms of small g. So in this formula I want to introduce small g. So let's get back and memorize the formula for acceleration due to gravity on the surface. You know, acceleration due to gravity on the surface, that is small g, is given as gm upon r square, right, on the surface. Now here, if I find out capital gm from this, I get gm will be equal to gr square. Let's put this value over here. If I put this value above there in place of capital GM, I get it as, yes, GH is equal to GR square upon R plus H the whole square. That is, GH is equal to G into R upon R plus H the whole square. And this is nothing but the expression for acceleration due to gravity at a height in terms of acceleration due to gravity on the surface. Clear with this? Now, let's understand the formula for acceleration due to gravity at a very small height. Okay? It's an approximate formula. Many a times when you are applying this in the sums, if the height is very, very small, 100 meter, 200 meter, 300 meter, then you can have an approximate formula. That is what we are going to derive here. When the height is considerably large, 2000 kilometer, 4000 kilometer, 6000 kilometer, then you will consider the previous formula what we derived. So let's understand an approximate formula for acceleration due to gravity at a height at smaller heights. So for that, let's start with the fundamental formula. You know, acceleration due to gravity at a height in terms of small g is given as what? G into R upon R plus H the whole square. Okay. Now let's take that capital R from the numerator to the denominator. Means what am I doing is, I am taking that capital R in the denominator, it becomes R plus H upon R the whole square. Right? In that denominator, that square bracket, let's split up the terms. Let's write it as R by R plus H by R. So finally what will I get is G into 1 upon 1 plus H by R the whole square. Clear till here? Now that 1 plus H by R the whole square in the denominator, let's take that in the numerator. So according to the law of indices, you know, it will become raised to minus 2. Means it will become equal to G into 1 plus H by R the whole raised to minus 2. Let's expand this using binomial expansion. So if I use binomial expansion, since the indices power is minus, it will be like one term, first term would be positive, second would be negative, positive, negative, and so on. And it would just go on increasing with the powers. Means the expression would be 1 plus 2 times H by R minus H by R raised to 2, then plus one more term of H by R raised to 3, and so on. Right? So if I consider the expansion of that brackets, I get it as 1 minus 2H by R plus H by R the whole square, then minus H by R the whole cube, and so on. Now, as I said, the height is very small, means H is very small and capital R is very large. So in that case, it's very clear that the numerator H is small and denominator R is very big. So H by R will be a very, very, very small value. And if it's a very small value, then its higher orders, means raised to 2, raised to 3, will be even more smaller. Means if it is 0.1, then 0.1 square will be even more smaller, 0.01. So approximately neglecting all the higher orders of h by r, what do I get? If I neglect h by r the whole square, h by r the whole cube and so on, I get finally gh is equal to g into 1 minus 2h by r, which is nothing but the approximate formula for acceleration due to gravity at a height which is a very small height considered. That is, gh is equal to g brackets 1 minus 2h by r, where h is a very small height, r is the radius of the earth, small g is the acceleration due to gravity on the surface, and gh is the acceleration due to gravity at that smaller height. Clear?